Okay, so in combined variation, you can have more than one situation going on. Maybe the volume, so I'll say volume, varies directly as temperature and inversely as pressure or something like that. I'm just making this up. Okay, but you have two things going on. So you're going to see the word and. You can have one be direct and one be inversely. Okay, so that's kind of what they're talking about here when we're combining variation. We're talking about combining direct and inverse. Okay, and in the next example, we're going to talk about a little bit more. Okay, so here it says, example 4, the owners of Rollerblades Plus determined that the monthly sales, S, of their skates vary directly as their advertising budget A and inversely as the price of the skates P. Okay, so let's put that all together. So this part A says write the equation of variation. So here it comes. This is part A. We're saying S, the sales, varies directly. Okay, so that's your equal sign right there. You're going to have a K. It varies directly as the advertising budget A and inversely though, so over P. E is the price of the skates. Okay, so there's the model. All right. Then we're going to continue, but the next that's part A right there. That's the equation. And then we have to determine, oh, I think maybe we have to, maybe I'm wrong that maybe that's the model, maybe that's not the equation. Maybe they want me to figure out K. All right. Let's figure out K. So it says when 60,000 is spent on advertising, so there's my A, and the price of the skates, P, is 80. Okay. Oh, then we're selling 12,000, that's S, pairs of rollerblades. So our sales are at 12,000. We don't know what K is, but we're going to figure that out. A was, the budget was for advertising was 60,000. And the skates sell for $80. Okay. So, there's a couple ways you could do this. I might write this as a multiplying by 80, right? So maybe 80 times 12,000 equals 60,000 K. And so let's see, what's that going to be? Divide by 60,000, right? So 80 times 12,000 divided by the 60,000. 1, 2, 3, 4. That's going to equal K. Now, I would maybe think about dividing this by 10 and making that an 8 and dividing that by 10. So, now I'm to 6,000. And then I know 6,000 is going to go into 12,000 2 times. So I'm going to say 8 times. So I'm going to say K is 16. And I would probably just do it that way. But you could put all of this in a calculator with all the zeros. That would be great. Okay, so we come up here and we're going to say the sales equals 16 times the advertising budget divided by the price of the skates. Okay, I'm going to say that's what they want for the equation. I don't know if they want the model or if they want you to figure out K, but you have to figure out K eventually anyway. Okay, so part B, determine the monthly sales if the amount of the advertising budget is increased to 70,000. Okay, so we were trying to figure out sales. We've got the 16 now. We know what K is. We've increased the advertising budget to 70,000. And we know the price of the skates is still 80. Okay, the price of the skates didn't change. It didn't say that. It's implied. Okay, so I'm just going to go on my calculator. 16 times 7, 1, 2, 3, 4, divided by 80. And I get our sales are at 14,000. Okay, and that would be pairs of skates. And how do we know that? That's how they were measuring sales and how many pairs of skates we were selling. Is that reasonable? We increased the budget for advertising, so should our sales increase? We think it's going to increase, so went up to 2,000 pairs of skates. Okay, so there's that example.